environmental sciences, and it's my real pleasure to welcome Dr. Ed Barbier here to visit us. Ed is somebody that we're really, whose work we're really interested in. He's had a real impact on understanding of how coastal ecosystems may respond to a variety of threats. And in particular, Ed's been really instrumental in bringing an economic perspective to things like ecosystem-based management and, for example, the role that vegetation plays in coastal protection. Ed did his undergraduate work at Yale University and completed his PhD in 1986 at the University of London. And he's had a very distinguished career and is currently John S. Bugas, is that how you pronounce it?
Bugas.
Bugas Professor of Economics at the University of Wyoming. What really turned me on, Ed's a very prolific publisher. He's published over 200 papers and a number of really interesting books. But what really got me excited are some recent papers that he's had in Science Nature that demonstrate his incredible ability to work with individuals from a broad spectrum of disciplines. And so this is very much in keeping with the interdisciplinary nature of the Urban Coastal Sustainability Initiative, which is why we want Ed to come here and talk to us and broaden our horizons even more. So Ed, it's a real pleasure to have you here. Please join me in welcoming Ed.
Well, thanks a lot, Jeff. It's a great pleasure to be here. This is the first time I've visited Northeastern. I've been to Boston many times, of course. Used to come up here for the Yale-Harvard games on the famous train. I don't know if any of you either from Yale or Harvard, but there used to be the famous trains between New Haven and Boston. And of course, I've been up here many other times. But it's a real pleasure to be here at Northeastern and be part of the Coastal Sustainability Initiative, which I think is one of the most exciting things that's happening in this country. And as I hope you'll understand from my talk, that I think the whole issue of coastal sustainability is extremely important. And I've made, I think, some modest contributions, but you can tell me afterwards. Today I want to talk about valuing ecosystem services for coastal wetland protection and restoration, some of the progress and challenges. And for those of you who are interested, there's a paper that's pretty much based on this talk. I was asked to do this for a special issue of an open access journal called Resources. So the paper is there and it's free, so you can download it. So if anything you find of interest, it's there. Today, what I want to do is talk first about why coastal wetlands and their services matter, and then the challenges of coastal wetland valuation, which is an area that I work in. And I want to do this by looking at 3 case studies. The first one is a case study of quantifying ecosystem services. One of the points I try to make is you don't have to do full valuation. Quantification can also be instrumental to policy. And a good example of it, which I want to talk about in this case study, is the 2013 Master Plan for Coastal Louisiana, on which I served as one of the advisors. And then the second case study, also drawing on Louisiana work, is work that I published with interdisciplinary colleagues from the University of New Orleans on valuing storm protection by marsh in southeast Louisiana. And I think I want to show this case study because it illustrates the challenges of doing valuation in coastal wetlands, where you really do need to have an interdisciplinary approach. You can't do it alone as an economist, you can't do it alone as a natural scientist, but through collaboration you can say something, I think, very unique about an important service like storm protection. And then finally, I'm also going to draw on another piece of work from Louisiana and the Gulf Coast, which is about oil spills. Obviously, we're interested in the positive benefits of coastal ecosystems, but we also want to know what happens when hazards occur, and how do we deal with restoration in the aftermath of hazards. And I think the example of oil spills and the natural resource damage assessment approach to wetland compensation is a very interesting case study worth looking at. And there's also a role for valuation. And then I'm going to make some summing up remarks. So just to you guys know this, but I just want to make sure we're on the same page, is that why we're interested in coastal areas is because of key global trends. More than a third of the world's population lives in coastal areas, and they only are 4% of the Earth's total land area. Coastal human population densities are 3 times that of inland areas, and of course, they're increasing. In developing countries, it's even more stark. Already 14% of the population and 20% of urban dwellers in developing countries live in low elevation coastal areas. So the future trend is more people crowded into cities, urban areas in coastal zones. And at the same time, while we're having that concentration of people in coastal areas, we're losing the natural habitat. More than 50% of salt marshes, 35% of mangroves, 30% of nearshore coral reefs, nearly 30% of seagrasses have either been lost or degraded worldwide. And then on top of that, we have these risks, these increasing risks of natural disasters. And what we're facing is that in the cities worldwide, more than 40 million people are exposed to the really big events, the 1 in 100 coastal flooding events. And by 2070, the estimates are that could be as high as 150 million people exposed to these events. So the world, as we see it, the coastal areas of the world as we see it, is one where population densities are pretty much getting concentrated in coastal areas. And as this map shows, we really have no pristine coastal areas left, except for the extreme latitudes of towards the North Pole and, of course, Antarctica. And in developing countries, you can see it's getting even worse than what we have in temperate developed countries. Not surprising, what we're seing is a decline in valuable services, the benefits that humans get from marine and coastal systems. In a paper that in Science, which by Boris Worm and myself and some others, we looked at the loss of coastal and estuarine ecosystems, and in particular we found that this loss has affected 3 critical services: the number of viable uncollapsed fisheries, the provision of nursery habitats such as oyster reefs, vegetation beds like seagrasses and wetlands that support offshore fisheries and wild species in the marine environment, and of course the filtering and detoxification services provided by a lot of coastal ecosystems. In addition, we also found that the loss of coastal wetlands and their vegetation has affected these systems' ability to protect against more coastal erosion and also flooding and other extreme events. There's also a link between declining water quality and things such as we see routinely now, like algae blooms, fish kills, shellfish and beach closures, and oxygen depletion. And more recently, we're starting to see the connection of the jellyfish booms that we're seeing in marine environments to similar factors. And finally, there's a connection between the loss of biodiversity in these systems and the susceptibility to biological invasions. Okay, so these are the things that we're starting to see matter in terms of declines of ecosystem services. We're starting to see trends like this, and we're seeing it connected to the degradation of systems. So why is it so hard and difficult to quantify and value these benefits? Well, the real challenge, as some years ago I participated in the National Research Council study on valuing ecosystem services from aquatic environments. And one of the things that the ecologists and economists could agree on is that the fundamental challenge here is tracing through from the ecological production and the functioning of ecosystems that are fundamental to these services to the benefits that you get. That's the difficulty. How do you trace from the ecosystem to us, to humans? And how do we trace through the quantitative impacts on the functioning and structure of ecosystems to the changes that affect human health, welfare, and well-being? And one of the problems is that all this happens outside of markets. If you go to the shops and you find that there's not much bread in the stores, you know that the price of bread will go up. If we have fossil fuels that get scarce, the price of oil and other fossil fuel products will go up. We don't get that with ecosystem services because they don't appear in markets. We don't go to the coastline and buy more storm protection per se. We can't go and purchase more support for offshore fisheries from having more wetlands. So what we have to do is go out and measure explicitly these values. We have to trace through these effects from the ecosystems to humans explicitly, and we have to come up with methods to do this and come up with the quantification. So the greatest challenge in all of this is particularly estimating the ecosystem services and benefits of some key ecosystem functions, which are regulatory and habitat functions. So most of you guys here have an ecology background, I imagine, so this is pretty basic stuff for you, but I just want to make sure we understand that ecosystem structure and functions describe the components of an ecosystem and its biophysical relationships. And this happens regardless of whether humans do anything with it. This is what ecosystems do. But a wide range of valuable goods and services depend on this structure and function. For example, some living organisms might be harvested for food or collected for raw materials. And then certain ecosystem functions, such as nutrient and water cycling, provide benefits, or the habitats that are provided by ecosystems support viable resources that we then harvest. Or we just like to recreate in nice environments. The bottom line is that although they are the source of ecosystem goods and services, the structure and functions of ecosystems are not synonymous with such benefits. What we have to do is say, well, what is the structure and functioning that's particularly relevant to this particular benefit or service? And that's what the challenge is. How do we say, with all the background stuff that's going on in ecosystems, all the possible structure and functioning, can we isolate those things that when they change, they cause changes in human well-being and health? And those things, the various benefits that come out of an ecosystem from its structure and functioning, that's what we call the ecosystem goods and services. And when we want to quantify these various benefits and their contributions to human wealth, that's what we're talking about when we talk about valuing ecosystem services. Okay. And it's a complex process, as this diagram shows. Why we're interested in this is that humans are changing ecosystems. That means they're changing the structure and functioning. As that starts to change, then we're going to have an impact on those particular goods and services that we care about, that affect humans. Now, the role of ecology is to try and help us understand the ecological production of those goods and services. But the role of economics is to then say, okay, if the ecosystem goods and services change, how do they affect peoples? livelihoods? How do they affect people's welfare and health? Knowing those values are important because we don't have markets to show changes in those values. We have to explicitly measure those to then understand whether the drivers of change are a good thing, bad thing, need to be modified. So this is the process that needs to be done if you want to understand how ecosystem services affect our well-being and how we can then modify and manage the environment to improve human welfare. It's not straightforward. So very few coastal ecosystem goods and services are bought or sold in markets. The exceptions are some raw materials, perhaps food and fish harvests. Other services, such as recreation, have been routinely valued in economics through non-market valuation methods. However, most key services of coastal systems do not lead to observable market outputs. So these include many of the services that we really care about, the ones that I mentioned earlier that are disappearing and declining the most, such as storm protection, breeding and nursery habitat, nutrient cycling, erosion control, and so forth. Okay, now this diagram, I know it's hard to see. We were trying to work on the projection of this, but on the left-hand side, I have the structure and functioning here of an ecosystem. And basically, it's the structure and functioning that leads to the particular services or goods that we care about. So coastal protection is up here, and down here would be things like tourism and recreation. Here would be maintaining fishing and foraging activities. So there's a huge amount of structure and functioning, but very specific structure and functioning that leads to each one of these goods and services, which then can be valued. Now on this right-hand side are some examples from coastal ecosystem valuation. And what you'd notice is that some of these things we're better at, or we've had more experience valuing than others. Others we're just starting to learn about. So for example, recreation has a long history in economics, and there's been a lot of studies connecting changes in ecosystem with recreation. So we're able to work out, so if there is a loss of a marshland, what does it impact on the bird viewing value of that wetland? And there's a number of studies that do something like that, or they value people's recreation in marshes that are relatively pristine. Increasingly, we're getting more studies of the nursery habitat, where people look at changes in mangroves or other marshes, how it affects the nurturing or breeding habitat of particular fish, which are then caught offshore. Ever since the Indian Ocean tsunami and the Hurricane Katrina, there have been more studies of storm protection up here. That is, as you reduce wetlands, how do you make the coastlines more vulnerable to future storm damages? Those are sort of things that are being done. But you notice as well, there's a whole bunch of blanks here. So there's some areas where we're just simply not getting enough studies done. And there are many other services and goods other than the ones listed here. So my bottom line is that because of the challenges in quantifying and valuing ecosystem services, of tracing through from structure and function to the goods and services to actually putting values on it in terms of the willingness to pay people to avoid bad outcomes, because of those challenges, we're rather patchy in what we've been able to do. And there's more work that needs to be done. Okay. But I'd like to go back to the first point I made and introduce a case study. Although I think it's important for many policy decisions to trace through from structure and functioning to goods and services to valuation, because it informs our decision making with regard to managing coastal ecosystems. It's not always necessary to go that full distance. In some cases, simply quantifying the changes in ecosystem services and goods may be enough to inform policy. And the example I want to start with is the example of the 2012 Master Plan for Coastal Louisiana. So some of you may not be familiar with this plan, but I think it's an incredibly important initiative. That in the aftermath of Hurricane Katrina, Louisiana went through a series of planning efforts to think about the next 50 years of coastal Louisiana. What do they want the coast to look like? And how does both infrastructure projects to reduce risks of damaging storm events, and how does restoration of wetlands figure into the future of the coast? And this is important because Louisiana contains about 40% of the wetlands of the lower United States, but it's also been the area where you've had the most wetland loss. And since the 1930s, they've lost close to 1,900 kilometers square of coastal land, and they could replicate this loss over the next 50 years. So the past loss has been huge, but if they don't do something in Louisiana, they're going to lose even more. Now, the 2012 master plan proposed to actually try and slow this process down. And one of the processes that they're going to do is actually restore lots of marsh. In fact, this is the largest planned coastal restoration that's going on in the United States right now. So over the next 50 years, they want to, depending on which part of the plan gets fully implemented, they're going to build anywhere from 500 to almost 900 square miles of new land. This is what, sorry again, the map's not great. This is southern Louisiana where the coastline is. The red shows you where the land's going to be lost if they don't do anything in the next 50 years. That's how much land is going to be lost. And one of the reasons for the loss is because of the amount of diversions that's been built and structures that have been built for navigation and for protecting the coast. It's taken away the water and the sediment that would naturally feed much of the natural coastline. So with the existing coastal infrastructure, there's going to be a little bit of accretion here, but you can see the devastating loss that's going to occur over the next 50 years. If they implement the plan, this is what it's going to look like instead. Is that there's going to be some loss, but you can see there's more creation than there is loss going on. It doesn't show up very well. There's some loss up here that you're going to see. So there will still be some loss of wetlands, but there's going to be some much more bringing back of wetlands. They're not going to go back to the 1930s, but they're certainly going to get rid of much of the loss that's planned. That is likely to occur. All right, so what was the role of quantifying ecosystem services in this plan? Well, they evaluated 248 restoration projects, and what they wanted to do is to understand what were the impact of each of these projects, as well as portfolios, different portfolios of all these projects, on 14 key ecosystem services. And of course, they're going 50 years into the future. Obviously, they could have spent a lot of money and tried to do valuation, but it's a very difficult thing to do. To think about. Remember what I said about the patchiness of valuation studies to date on coastal ecosystem services. They simply would not have had the information to do very realistic valuation studies of all 14 of these services, much less plan it for the next 50 years. So instead, they focused on proxy characteristics of the coast that are most connected to each one of these services, such as provision of habitat. So they use habitat suitability indices to proxy some of these services. And then they use other factors, biophysical and ecological, that they know are connected, or the scientists know, are connected to each one of these services. Now, not only, as I said, were these various metrics used to evaluate each individual project effect on ecosystem services, but it was also used to examine the collective coast-wide effect of groups of projects on these services. And not only that, but they looked at the effect of the restoration projects along with the new infrastructure projects. So they looked at the combined effects of the two types of projects. This table here is just summarizing how they did it, how they looked at, on the left-hand side, this is the 14 services that they considered important. Now, these aren't necessarily services as we would define them in economics, but they, to me, are in effect the indicators that you would want, the services and goods that you would value coming out. And so I was reasonably happy with this list. And on the right-hand side, this is how they actually use proxies and quantitative indicators to show the state of these services. Now, obviously, there's some limitations. One of the problems is that for specific species that are harvested for commercial or recreational purposes, such as alligators, crawfish, oysters, using habitat suitability indices seems to be a reasonable proxy. So if the service is something that's commercially harvested using an HSI, seem to work as a good proxy. But difficulties arise for using habitat suitability indices for other species, such as waterfowl, which aren't commercially harvested, but are really connected to recreation. There, an economist would prefer to have some kind of recreation valuation study. So when you use HSIs for waterfowl or for other coastal wildlife, then it's really hard to know what the ultimate benefit is to humans of having more of these species rather than less. We think there's a connection, but what actually is difficult to measure. When you get into some of the other regulatory services or services connected to regulatory functions like quantifying nutrient uptake, carbon sequestration, freshwater availability, and storm surge wave attenuation, then it's much harder to get HSI and other ecological indicators to be more reliable indicators of the value of these particular types of services. Okay, nonetheless, I think there's some important lessons learned here. One is that quantifying ecosystem services using indicators as a guide to policy making can work. And they were able to use these indicators to show the shifts in key habitats along the coast that would occur under the different scenarios, different portfolio options, different project options. And that's the sort of thing you want to get towards, some kind of indication of how are things going to change and what are the key ecological factors that are going to change and indicators as a result. And you're getting something closer to trade-offs here, which is what you're after in economics. They learned some things too. They learned that the projects that ultimately were selected by policymakers out of the master plan were likely to provide larger benefits in terms of increases in alligators, freshwater fisheries, and waterfowl habitat. But some other habitats weren't going to change too much. Coastal wildlife, shrimp and saltwater fishery, they're likely the same at the current levels. There may be, in particular, an impact on oysters, but that's across the coast. In some areas within the coast, they found that oyster habitat is going to increase. So although there may be an overall decline in oyster habitat, which is an important fishery in the area, some coastal areas are going to see increases. And that could help plan as to where you want to have the increases occur. Freshwater would increase by 40%, and they found increases in carbon sequestration and nutrient uptake. And there would be some positive impact on tourism and possibly agriculture. They also were able to say, well, we're going 50 years ahead. How did this fit in with climate change scenarios and predictions for the next 50 years for the coast? And they worked that in. both for climate change and sea level rise. Again, the idea is not to say this is the best plan, this is the best portfolio of projects, but to offer to policymakers a range of options and possibilities. If you choose this suite of projects, as opposed to this one, this is what the coast might look like, this is what the ecosystem services might look like, this is how it could change under each scenario, given this scenario for climate change as opposed to that scenario, and so forth. Okay. My personal view, this is my bias, is that I think there are some services that are incredibly important that do need specific valuation. And one of the ones that I think is worth examining is the valuation of storm protection services. And in recent years, while we were working on the master plan, or I was really an advisor, I wasn't really working on it, I nonetheless had the fortune to work with some scientists at New Orleans University to look at how marsh might protect protect property in coastal areas and how to value them. This is the paper. It appeared earlier this year in PLOS One. And basically, there's more and more field studies by ecologists indicating that coastal marsh vegetation significantly impacts wave attenuation. By that, it means that the presence of these marshes slow down waves and also reduces the height of waves. And as the waves cross a wetland, you start to see this effect occur. So what we did is that we had a hydrodynamic storm modeler take some storm simulations from existing storm circulation storm models for Louisiana, and we actually included in data on the presence of marsh along these predicted storm transects. And the storm transects were the transects of the storm surge of the predicted storms. And we were able to then work out whether the presence of the wetlands, as well as their vegetation, would slow down the waves. And if so, using data from the Corps of Engineers on property damages to flooding in southeastern Louisiana, we're able to work out the impact on flood damages. This diagram here shows you the area we're working in is the Carnarvon Basin in the Gulf of Mexico, heading in towards southeast Louisiana, and particularly New Orleans. And the white line there is the transect analysis. That's the path of the predicted storm surges. There's New Orleans there. And the next slide shows the water depth, which is and the presence of the bathymetric data that we used for the wetlands. We also had information. This diagram, it doesn't come out so clearly, but you normally would be able to see that the types of habitat, that is the presence of wetlands or not, as well as their vegetation, as well as their depth to the surface of the water. And what we found is show that maximum wave attenuation, this is the wetland water ratio. So for each segment of that transect, we looked at what's the percentage of that segment that's covered with wetlands or not. That's the wetland water ratio. So 0 is open water, and when it's 1, you have a completely solid marsh. And what we saw is that wave attenuation, which is the reduction in the storm wave, is positively correlated with wetland water ratio. We also saw that same thing with vegetation roughness. There's something called Manning's N, which is the friction coefficient for slowing down water, which hydrologists use for slowing down the speed of water as it passes over any given land area. And again, 0 shows no vegetation, and 1 shows complete healthy vegetation. And once again, you see that wave attenuation increases, that is the reduction in storm surge, as you have more vegetation roughness, which is a sign of the health of the vegetation of a wetland. I apologize for this. But basically, this is after we did all the evaluation. So once we had that physical information, we could estimate the relationship between both the presence of wetlands and storm surge, as well as the effect of vegetation roughness on storm surge. We were able to look at two things. First of all, this is our prediction of the change in storm surge due to changes in wetland vegetation, the presence of wetland, and also wetland roughness. And also over here, we measured the estimates of the damages on property. And we found significant effects. So what we learned was the following, that a 0.1 increase in wetland continuity, which is the presence of wetlands, per meter, reduces property damages for the average affected area in southeast Louisiana by about $100 to $130. And we also had an impact from vegetation roughness. What that turns out to is that it turns out to be the equivalent of saving 3 to 5 and 1 to 2 properties, given average property values, per storm for the average subplanning unit of southern Louisiana. That's significant. So there's a significant impact on saving properties. What it suggests is that wetland restoration could reduce the future vulnerability of the coast to periodic hurricane storm surges and decrease the risk of substantial flood damages to residential property. But of course we need better information from hurricane and other tropical storm surge models to improve on the estimations of the distribution of expected coastal flood damages. And of course it'd be nice to do this elsewhere. Since Hurricane Katrina, there's a huge amount of modeling work that's gone into modeling future storms and storm surges for this particular area and basin. It'd be nice to do it for, let's say, the eastern Gulf Coast. We don't have that information yet. It would be nice to do it up here. We don't have that information yet. But once we do, it would be possible to do similar stuff. Last case study I want to talk about is oil spills. Now, you know there's a constant theme I've been talking about here, which is a shift in mentality from wetland loss to think about wetland restoration. Now that we're starting to accept that maybe wetlands are valuable and they confer important benefits, maybe we should include them in our future plans for the coast. We also have a long history in this country of restoring wetlands after damages. And of course, the 2010 oil spill in the Gulf is a good example. So I was asked a couple years ago to write about coastal wetland restoration in light of the Deepwater Horizon oil spill. So what I looked at was how do we use valuation in our current efforts to deal with natural resource damage assessment after spills? How do we use this information to plan restoration? And what I found was several things. First of all, one is that since the 1990 Oil Pollution Act, we have the legislation to do this, and we are increasingly, particularly with oil spills, looking at including in our damage assessment both the cost of cleaning up these releases, but also the monetary compensation needed to restore natural resources. And it's NOAA, the National Oceanographic and Atmospheric Administration, that has the responsibility of doing natural resource damage assessments, which is the basis for making these compensation and damage claims. And what I found out, however, is that prior to 1990, the NRDAs that were in place used economic valuation. Now they tend to use something else called habitat equivalency analysis. What is that? Well, in NOAA, basically what habitat equivalency analysis is saying that if you damage a wetland in a particular location, you can restore that wetland, but what you can also do is create a wetland in a different location as compensation, provided it provides the similar habitat ecosystem services. So it involves 3 steps. First, you got to quantify the interim losses that arise from the damages. Interim's important because sometimes the losses are not permanent. So if you have an oil spill in an area, it may cause permanent damage, and most often it's going to take time for the services of that particular damaged wetland to return. In that interim period, you want to know how much was lost and for how long. Then you want to have the scale of compensation, restoration, required to offset the services loss. So if we lose for an interim period a certain amount of recreation services or nutrient recycling services, how much wetlands do we have to create somewhere else to compensate for that interim loss? Okay? And then finally, the responsible party pays for it. We go collect the damages, paying for the compensatory wetlands. What this means is that it looks like we're doing something which I talked about before, just quantifying the services and not worrying about valuation. That's true. Valuation is not necessary. This really involves comparing services to services. The services loss while the wetlands is recovering with the services gain for where you're going to restore elsewhere. And this is what it looks like. All right, so basically what happens is, supposing a wetland experiences at time t a damage. So you have a loss in interim services, and what happens in this case is that what you want to do is you have compensatory at some future time while you're losing, while the system is recovering, you put in services, put in a wetland somewhere else, and you have compensatory restoration. So at some time t, eventually what happens is that during the interim period you have primary restoration, and in addition you have other expansion going on if it continues on. Okay, let me give you an example. It's easy, this is all theoretical, but let me give you an example. And this is not the deep water horizon, but this was another spill that occurred in Louisiana, much smaller scale. It was due to a pipeline burst. So Texaco had this pipeline that ruptured in the late 90s. It discharged a huge amount of oil into Lake Barre, Louisiana. Lake is really an enclosed area off the coast. It's not really a freshwater lake. It's as such. So over 4,000 acres of estuarine salt marshes were affected, and more than 93% of the affected areas suffered only limited services losses, with full recovery occurring after 4 months. But the habitat equivalency analysis said during this interim period, so it was a pretty quick recovery period, Texaco had to replant some marshes somewhere else. So what they did is that they chose a new area, an area called East Timbervalier Island, to recreate marsh, and they also figured out, due to vegetation spreading, eventually it would reach 58 acres. That was done. And Texaco agreed, they paid for that, and that's what happened. This is what it looks like. This is Lake Barre, where the original spill occurred, and over here is where they created new marsh. So at the end of 4 months, you had pretty much recovery, 4 to 6 months, you had pretty much recovery of the Lake Barre marshes, plus you had the new marshes created on this island. That's how it works. What's the pros and cons of this? Well, good thing, I suppose, is that restoration is emphasized from the beginning. You also get rid of a lot of protracted litigation costs. You don't have to worry about it because you do the NRDA and the HEA, habitat equivalency analysis. You present the bill to the people liable, the agent liable for the damages, and hopefully there will be an agreement, and then you just proceed. It ensures, therefore, that enough money is collected to do the restoration. And then finally, it's not necessary to conduct valuation studies. It's done, like I said, on a service-by-service basis. What's the cons of all this? Well, from an economic perspective, there's some problems. First of all, we got to assume that you can compensate in this way. You've got to assume that, let's say, putting wetlands on a completely unvegetated island like East Timberlake is going to compensate for whatever people's values were attached to the damaged wetlands. Do we know that? It assumes also a fixed proportion of habitat services to habitat value. Remember what I was talking about with the Louisiana Master Plan. If you're talking about similar habitat for a similar species, such as shrimp, maybe the two can compensate the same. But what about recreation? Would people really want to go out to East Timberlake when they were recreating around Lake Barr? Would they get the same benefit from recreating in the other place as opposed to the original one? What's lost and what's gained? This assumes that they're proportional, but it may not be. These are related to that. But here's another problem, is that you could end up with too much. I mean, at the end of the day, you end up with the original wetlands coming back, but you also have some new wetlands created on an unvegetated island. Is that a good thing or a bad thing? Maybe bad from both an ecological and economic perspective. What does it mean to create wetlands on an unvegetated barrier island? Ecologically, it can have some important impacts. This is an example where you show, this is the actual study that came out on demand for wildlife. So we're going to stick with one service, which is wildlife recreation. So people like to go view wildlife, and they like coastal wetlands because you've got lots of waders, maybe some alligators you want to see, and a few things. So imagine that you had, this is the baseline. Okay, so at time t, before the damage occurs, this is the supply, if you like, of the service. This is the demand for the service, right? So the demand for service is this. Then you have the damage, and the damage would reduce the supply to this. Obviously, people would be willing to pay more because they've lost some valuable habitat that they would have for recreation. But now you go and you create wetlands somewhere else. Well, two things may happen. It may be that people start to switch, and they do go recreate elsewhere. And then you have maybe twice as much wetlands for recreation. Well, what happens in economics terms is that you're shifting the supply of wetlands capable of providing the same recreation out here, and it exceeds the original demand. So in actual fact, by doing this, you've actually reduced the value of wetlands for recreation purposes because you have too much supply. Same thing would happen if you suddenly, you know, pick any commodity. If you oversupply it, the value of it goes down because its supply exceeds demand. This can happen. Here's a more important problem, is that this is something that we often don't know, is that one of the problems with HEA is it's saying costs are as good as benefits. As long as we provide the same services, the cost doesn't matter. Whatever it costs to take it, to provide the same services, it's worth the benefits. That may not be the case. Why? Well, the wetland that exists before provides the service with no cost. Okay? So the original wetland, without being damaged, is there. It doesn't need any human input to provide the habitat and the various services that matter. So the supply curve is effectively zero. The supply curve is the marginal cost, the additional costs of providing the service as you have more of the wetlands. It's zero. So it's along the horizontal axis. This is the demand for the service. very much like the demand for recreation. But this supposes a demand for all the services, recreation and demand for the fisheries that are supported by this wetland, the demand for storm protection service. Suppose we aggregate it, that's the demand. Well, beforehand we get this huge value, which is the difference between the demand over the supply, and that's the benefit, the net benefit of the pristine, undisturbed wetland. Okay? But now, we're saying, all right, let's suppose we go find another area, recreate the wetland. Now it's going to cost us something. We're presuming that the cost of doing so is not going to be obviously zero, so we're not going to have the pristine wetland. We're going to have another cost. But suppose the cost is really, really high of creating wetlands elsewhere to provide the same level of service as before. Now, the net benefits is actually a loss because the cost of providing the same level of service is so expensive relative to demand that we have a net loss called area B. That's the danger of using costs or saying if we're going to aim just at creating the same service, what's going to cost us. Which is why we need to know this demand. We need to measure the willingness to pay or the benefits for the service. Because we could decide that the best thing to have done would be to put more money into trying to restore the original pristine wetland to what it was before, particularly if it takes a long time for it to recover. The Lake Bar example is just 4 months. But often recovery is much longer. And we might need to spend more money on this to achieve the same level of benefits than doing expensive restoration elsewhere. What are the lessons learned? Well, coastal wetland restoration and compensatory mitigation are going to feature into future efforts in Louisiana and other coastal states. We do need to develop methods for assessing it. So I'm not knocking the methods of assessment per se. I'm just arguing that there needs much more consideration of the long-term ecological establishment of wetland structure and functions and of the economic benefits derived from wetland goods and services. I think it's not sensible to say we can always get rid of valuation by just ensuring that services be replaced with services. It may not be ecologically feasible, and it may be economically feasible and economically more expensive in the long run. So here's my final remarks. I'm pleased to say that thanks to the interest of policymakers, scientists, and economists, and the general public, there's been considerable progress in valuing key goods and services provided by coastal wetlands. The point of valuation is that it can identify trade-offs, including the costs and the benefits of various coastal management options. And therefore, it has a role to play in assessing management effectiveness. However, there may be some cases where you don't need to go the full hog and do valuation. You can get a lot of information just out of quantification. If employed properly, both quantifying and in some cases valuing coastal and estuarine goods and services will, however, aid decision making by policymakers and local communities. And I think this is very valuable given the trends in coastal populations, decline of estuarine and coastal systems, and of course the valuable services that matter. So I hope this continues to be an important area, and I appreciate greatly you guys inviting me here to talk about it. Thank you.
We have time for some questions. I'll get started then.
Thanks, Jeff.
The first thing I noticed was how different the valuation of continuity versus vegetational type level in your second case study.
Yep.
And what that suggests is that really, the thing that really should be targeted is continuity, at least in terms of that particular metric that you're measuring for.
Yeah.
What I wonder is what's the trade-off between, you get that kind of outcome for, in terms of the impacts of continuity,
yeah,
based on the variable that you're measuring, But something like vegetation, that could be much more beneficial to a variety of species that rely on elevated vegetation height, et cetera.
That's true.
So how do you resolve? I mean, I guess the point of that, and it's a point that sort of permeates a lot of what you talked about, is a lot of it's very, very context dependent, right? You know, for example, with the last graph that you showed, I mean, you're talking about baselines, but the baselines that we're dealing with are severely already impaired, as demonstrated by the beginning of your talk.
Yeah.
So how do we reconcile?
Right. Let me get to the first question first. On the storm protections, it's just one service. So that there is this problem. That sure, presence comes first, but you could also think about this. Without the presence of wetland, you wouldn't have the vegetation roughness, so they're kind of joint products.
Sure.
But not necessarily, because one of the things we're finding in restoration efforts is there's good restoration, there's bad restoration. There's also different levels of degradation of wetlands. So what we were pleased, this is the first study that's ever done that type of analysis of combining hydrodynamic simulation of storm surges with physical presence of habitat with property damages to come up with a valuation. But it was also the first study to include not just the presence of wetlands or just the area of wetlands, but also some measure of its quality, which is the vegetation roughness. And I think what we tried to show is that there's an additional value added, the additional benefit, if you like, that you're getting from having good quality wetlands, i.e. those with healthy vegetation, as opposed to degraded or poorly restored wetlands. And I think that's the valuable lesson there. Absolutely, restoration is location dependent, and you've put your finger on it. The dilemma we face is that because we don't have enough valuation studies already, that we don't have good baselines. And in some cases, we don't even have good ecological baselines, which Brian knows a lot about. And this is where it's becoming more important, is that we're losing a lot of coastal wetland areas at a rapid rate. So where do we get these baselines from? It's a difficult situation, but we do need that, and that's why I think it's really more urgent that we go for we start doing this more and more of these studies right now, and obviously there's some key services to do, and we've done a better job with some than the other, but it's the ones we don't know about that we really have to do a lot more work on. I think what worries me the most is I think one of the more possibly important services that we're not capturing are water quality effects of coastal wetlands, and and also upstream downstream effects. So, for example, a former PhD student of mine, now assistant professor George Mason, he and I were looking at water inflows in the upper Georgia watersheds, how inflows of water were affecting the blue crab fishery down below. And this is really important because Georgia's gone through some droughts recently. And so the water flow is changing, and there's two effects of the droughts. One is, of course, the fact that it starves off water to the fishery, but also the policy response to the drought is to divert more water for urban and residential and industrial use. So that even worsens the ecological impacts of the drought. And they're thinking that that's because the water is valuable for those uses, but it may also have an impact on the fisheries that needs to be managed. And you see that a lot in studies. Yeah.
I think you hit the nail on the head with the part of here that bothers me the most, this idea that you end up with more habitat than you originally started with.
Yeah.
And I've seen ecologists at NOAA and the academic community argue that they should apply discounting rates because it even magnifies that problem.
Yeah.
Do you think NERDA is going to move beyond here and start to use more valuation approaches, or do you think we're stuck with it?
That's a good question. It's a question I want to ask my friend Linwood Pendleton, who's the chief economist at NOAA, and I think his term is finally ending up. Because here's the problem, is that there's just him, or there has been just him. And there is 5 million, not that many. Not only do we have too many wetlands, we may have too many ecologists, or at least relative to economists and NOAA. Sorry to be so disciplinary snobbish here, but here's the problem: is that these are big issues, and these are important issues. I'm not sure discounting is the only thing to do with it, but we do need to. We kind of went overboard in one direction, and on one level, I like the idea of habitat equivalency analysis. And I like some of the pros. I mean, we were up to then just swamped with litigation, just so that no compensation was taking place, just delayed. And the Exxon Valdez is the classic case. So in some ways, this was all a reaction to that. How do we speed up the process? How do we get more money on the ground for restoration? But I think we've gone overboard in that way. And now we need to think about when's the right time to apply this HEA approach, or when's the right time to do something else, evaluation. And Jeff put his finger on it. I mean, if you don't have baselines, how can you even do this? And they're doing it without baselines, ecological or economic. They're just saying, right, we think, go out there and we'll just decide to do this. And also, when should we just put more money into restoring, the original wetland, put more money into that rather than doing this compensation? But the whole ethos has changed to this compensatory or mitigation wetland, and there's problems in the freshwater area. But now that we're seeing coastal wetland restoration just take off, we're replicating the same problems that they're seeing with wetland mitigation and wetland banking in freshwater areas, in the coastal areas. So I think there needs to be some serious rethinking in NOAA and in the NRDAs, and get more economists involved to help out working on it.
So you didn't really talk about marine protected areas or coastal national parks. So how do you see those as influence of this evaluation of these coastal systems and establishing those baselines of environment?
That's fine. Coastal areas are helpful. I mean, coastal parks, but as ecologists and coastal scientists will tell you, you can go 20 kilometers or 15 miles down the coast, you get a completely different system. So it's really hard to ecologically transfer, say the benefits are the same in this wildlife refuge on the coast or this park and an area 15 miles down the coast. It might be very different. So, but from an economic perspective, you also get very different benefits because you're going to have specific benefits or uses tied to the park or the refuge that you wouldn't get 15 miles down. So for example, you're likely to have more recreation values from the park, but less down the stream or along the coast. You might have more benefits in terms of oyster fisheries or other kind of reef fisheries, where we've seen some trade-offs as we got to with the master plan. Some oyster reefs don't really need oyster beds don't really need the protection of wetlands. In some ways, they actually benefit from removal of wetlands. So you got to look at those trade-offs too, when they occur. And of course, you can't go to the national park and start removing wetlands and see what happens to the oysters. That's not a good idea. I wouldn't recommend that. So there's some things you can do and can't do, field experiments. I think there's a lot in simulation. I think one of the things I learned from the master plan is how much these scientists know already and are able to simulate things and develop complex interactive models, to the point where they could predict, the coastal engineers could predict if you change water flows and sedimentation rates and delivery in certain areas, how's the rate of creation of new wetlands will occur. And then the geomorphologists could say, well, if you combine that with certain bathymetric and slope characteristics, what type of wetlands would you get? What type of vegetation might you get? And then the ecologists on top could model the type of habitats and species that might come back in those areas. That's pretty cool to overlay those models. And then, of course, the GIS guys can come in and show the spatial implications of it all. That's pretty neat. And I think so modeling is going to help us do that kind of thing. Yeah. Right.
So it seems like the big unknown here is public perception. So I'm trying to wrap my brain around this in kind of an insurance analogy where, you know, if you live in a $100,000 house, you're not willing to pay as much for insurance as if you live in a $1 million house. So is an advantage of valuation that people see the value and are willing, have a higher willingness to pay? And kind of following that along from what Nick said, are people more willing to pay to protect something that's 5 miles away than 15 miles away? And how does that affect the valuation once you add in that public perception on kind of a spatially explicit basis, if that makes sense?
Right. I think I'd turn it around and say they're unaware of how a marsh 5 miles away may actually protect their value. And if you provide this information, then maybe they will.
Exactly.
They know. I mean, right now we've been doing it all ex post. We've been saying, okay, this flood came in, caused this much damages. Why did we remove all those wetlands and what effect did it have? Well, ex post, it's really hard to do that because they're gone, the wetlands. And then the next thing is to say, well, how do we best protect it? We put in barriers, barrages, levees, you know, physical structures. Well, if you do that, you're going to change the water flow and the sediment delivery, which is going to affect the remaining wetlands, and it just goes on and on and on. And so that gets back to what we've been talking about with these excellent questions. Is that if we can start to model some of this and do some more predictive ex ante stuff, like what I showed with this, we can perhaps show people that the presence of wetlands along hurricane transects can reduce the value, and also tells us the models could predict to us which transects are most likely to occur more often with certain storms. We can also work on this. We only did 4 storm surges, but we could do this for lots of storms with different characteristics. One of the things I didn't show you, it's in the technical analysis behind the PLOS one, is we actually did base this on predictive values of storm characteristics. So we could also put in the extreme one if we wanted to. But we used the standard ones. Yeah. Yes, you've been trying to ask. Sorry.
So my question is sort of the next iteration of Alliance. How do we get different stakeholders to pay attention? So the modeling might be there.
Yeah.
The quantification and the assessment.
Right.
How do we grab attention of local communities, planners, policymakers?
Well, one of the great things, I'm glad you asked that. You've got to read the master plan for Louisiana, 2012 master plan. One of the, I think the greatest things they did was build into this plan a huge amount of community stakeholder outreach. And there was, parallel to all the scientific work, so I was on the advisory board, so I wasn't doing any of the scientific work of it, but I was able to, as being an advisory board member, get feedback on how these guys were going out to the local communities. And it was huge. I mean, they were making not only just town hall type meetings, but they were going out and using local NGOs and community groups, meeting with legislatures. And if anybody is familiar with Louisiana, it is a political nightmare. You know, I mean, there's a reason why Huey Long came from Louisiana. I mean, it is so disparate. It is, you know, it's tough. Yet when this plan, and people thought this plan is dead in the water, you know, when we first started working on it. It sailed through the legislature. Bobby Jindal, who's the governor, is not exactly, you know, Chris Christie. I mean, he might think he is, but he's not. He was for this, but he's politically to the right, and you know, he's not exactly being one who's going to support something that's going to involve a huge amount of public investment, because that's not his political creed. But he did. And so did a whole range of legislatures, from very urban parishes to very rural ones. And as did a huge amount of stakeholders. Probably the only group that was against it was, you can imagine, or those lobbies representing the oyster fishermen. But the crayfish, the shrimp, the mac, all the other fishermen groups were all for it. And the Corps of Engineers was also involved. In helping it, because the Corps of Engineers have a huge stake in this part. I mean, they basically created Louisiana the way it is today. they straitjacketed the Mississippi River. And they created that famous bird claw. Whereas the Mississippi River before was this hugely diverse thing. What you see in western Louisiana with the bayous and all that, that's what the bottom part of Louisiana used to be like. Anyway, my point is that this was a smart investment by the Coastal Protection Restoration Authority to put so much money into community outreach, social things. One of the things I'm doing as a follow-up is that there was a creation of this Water Institute of the Gulf, which is a science think tank based in Baton Rouge that's going to be, one of its responsibilities is to provide more scientific input for the implementation of the plan as it moves forward. And one of the things they want to do is create some socioeconomic guidelines for assessment of these projects as they start coming in. So I'm going to, with a sociologist and a lawyer, help them frame some questions for these guidelines. So the outreach happened, and it's going to continue to happen as we move forward with this in Louisiana. And I think it's absolutely necessary to have that element, because otherwise, what's the good of having papers published and just sitting in journals so the rest of us as academics can learn from them if you don't go out and sell it to the public? Because there are so many diverse stakeholders. And there's been huge misconceptions about coastal areas by people for so long. It's only recently that we've been talking about restoration. Up to now, we've treated wetlands in coastal areas as just wastelands that need to be, their only value is converting them to something else that's valuable. Marinas, you know, shrimp farms, residences, that stuff.
Well, one last quick question, because we've been talking about 10 to 15,000 feet right now.
I like to do that.
Yeah, my question for you, I mean, the devil's always in the details, and I wonder if this detail really matters if you think it matters, which is that back in the lake example where you had the impacted marsh, and you restored it later in another area, you know, there's the issue of location, but there's also the issue of, you know, an old hemlock forest functions very differently than a young hemlock forest.
Absolutely.
Therefore, the services that are delivered are developmentally explicit. And so the question is, you know, when you can't necessarily do an acre per acre comparison for the wetland that was impacted and the amount of wetland that you're going to restore. Right. Is that figuring into the calculus at all, or?
That's exactly what they're doing, I'm afraid, though, Jeff, is they're actually saying,
so they're
over those 4 to 6 months that we're losing these wetlands due to the damages, how much wetlands do we have to create somewhere else to compensate for those lost in services? And that's what they did. And they said, well, I showed you that, some 11.3. I mean, how did they come up with 11? Why not 11.4, 11.1? You know, but that's what they did. And I'm not convinced that they knew exactly. I mean, I've seen this also with mangroves. You know, I've done a lot of work with mangroves. Is that mangroves are a lot easier than marshes in some ways because there's so fewer species per tropical area. So people think it's so easy to restore them. It's not. And also, the problem is that with restoring mangroves, what people tend to do is plant mangroves on unvegetated tidal flats because it's cheaper to do it. You can get more mangroves. But it's also a good reason why mangroves weren't there. They're in sheltered bays and they're on, you know, and yet, so what's the point? And you also are usually choosing the easiest species to replant. Whereas it makes a huge difference in mangrove forests if you have 2 or 3 species as opposed to 1. It may look the same, but it's very different in terms of the services. And the one I care about, the service I care about recently has been storm protection. You put mangroves on unvegetated tidal flats, they're going to get wiped out by a storm, and even if they do survive, that's not where they were for their natural protection. You don't get as much bang for a buck. And I'm afraid there's too many decisions like that, where it's like, well, we want to put the wetlands here because that's where the land is cheap. It's where it's least costly to restore them. And wetlands are wetlands. They've got it, surely that, you know, we're creating a marsh here. Surely it's the same as the marsh where they originally were. Meanwhile, we'll put marinas there, you know, because it's a prettier place for marinas. Yeah.
So I like the idea of kind of valuing these ecosystem services, and I think it's probably easier to...
Good, you get an A for the day.
It probably makes it easier to communicate to the public and kind of distribute that effort. But I can see once you start kind of turning everything into one unit, as far as like money, and you're kind of reducing, it's very easy to reduce the complexity of an ecosystem relative to, say, using ecosystem equivalency. And is there any concern that once you turn it all into one unit, that relative distribution of value gets kind of shifted around in the restoration effort? So more of that money is now put toward preservation of property instead of, say, preservation of the fisheries, and say, preservation of that real estate, which is obviously more important to many people than, some of that value that you destroyed is taken away from other things.
That's a good question. I mean, I think the key thing you want to start off with is what are the services that matter in this particular context? And then you want to ask yourself, how do we quantify those? And then secondly, which ones do we need to value? And in that last question, it's really a question of where are the changes and benefits that matter to humans that are affected most. That's important, but that shouldn't be the only criteria. That is an important criterion, because after all, for the reasons I showed, how many millions of people are in coastal areas. And for the point that Brian raised, is that often it's not obvious that someone's house half a kilometer in from the coast might be affected by a coastal wetlands or its disappearance 5 miles outside. You don't see that. You don't see that when you build your house. You don't see it when people are planning about it. It certainly does matter to the people who live there, and it sure matters to coastal planners. But that may not be the only criteria. That should not be the only criteria. Getting back to Jeff's point, for example, vegetation roughness is an indicator of the healthy vegetation. In our case, we were valuing only its contribution to protecting properties on the coast, but that healthy vegetation, I know, generates many other services and values. If I was interested in valuing just the services, all the services of wetlands in that, let's say in Carnarvon Basin, I certainly would want to look at more benefits and some of the things I couldn't maybe value, but also want to quantify as well. Or even some things that I think might be of future interest to people. But at the end of the day, no one has ever done what we've done, so it's a first step. And sometimes you have to do that. Everybody wants our kids maybe, to become a soccer star, but first they got to learn to walk, maybe go to school. We're kind of at that stage with valuation ecosystem services. We got to learn how to walk before we start planning them playing for NC State soccer team.
Well, please join me in thanking Ed.
Thanks, guys.